All right, this is our next video dealing with solutions. And in our last video, we learned about what are called colligative properties. And as we learn from colligative properties, we learn that certain things change, like the freezing points and boiling points of solutions change, depending on the concentration of the solution. And we learned a couple of equations, delta TB equals KB times the molality, and then the same equation with freezing points. So now basically what we're going to do is we're going to keep using these same equations, but we're going to be doing something a little bit different. We're going to be talking about the molar mass of a substance. So when you're dealing with solutions and they're talking to you about molar masses, one of the ways you can determine the molar mass is based on the freezing and boiling point of the solution. So we're going to be able to calculate the concentration of a solution and the molar mass of a solution based on the colligative properties that we have found. So just a quick review from what we've talked about the last day or two. We're going to be using our notes. Maybe we'll use a little bit of our brains. Let's talk about what the answers to the following questions. Number one is, what is a colligative property? A colligative property, remember, is a property that depends on the concentration. And in this case, the concentration is the molality. That's an I, sorry. The molality of the solution. A couple of examples that we've seen of colligative properties. One of them was the antifreeze in the radiator. And that keeps the water from boiling and freezing by raising the boiling point and lowering the freezing point. And then another example we talked about could have been something dealing with the salt in the water when you're cooking things. That causes the boiling point to go up instead of staying right at 100 degrees. So when we use freezing and boiling points to determine the concentration of the solution, we want to think about what unit of concentration do we use when we're doing this. And that was something that we learned in our last lesson. Anytime we're dealing with freezing and boiling points, we only use molality. Okay? As I told you a few lessons ago, when you are using concentrations, typically you're going to use molarity. Molality, really the only time you use molality is when you're dealing with freezing points and boiling points. So we can use this equation, delta TB equals KB times M, to explain what information is needed and how we would solve for the molality. So if we had a solution of sucrose, it freezes at negative 1.25. What is the concentration of this solution? So kind of like what we did the other day. The other day, though, we were given the freezing point constant, and we found a way to find the molality. And then the goal the other day was to find the boiling point, or the change in the boiling point, or the change in the freezing point. So now what they're asking us is they're saying, okay, we're going to give you the change in the freezing point or the boiling point, and we're going to give you KB. What we want you to find now is we want you to find the molality. So a solution of sucrose and water freezes at negative 1.25. What is the concentration? And again, when they say concentration, they're meaning molality of this solution. So we know the change in the freezing point is 1.25, excuse me. So 1.25 is our delta TF. So basically it's this same equation right here, but delta TF equals KF times M. And we know that the freezing point constant for water is 1.86 degrees Celsius over M, and then our unknown obviously is our molality, our M. So to find the molality, we're going to take 1.25 and we're going to divide it by 1.86, and we get a molality equal to 0.672. Now remember, 0.672, we can write that as little m, but remember we can also write it as 0.672 moles over kilograms. And remember, the moles are the moles of our solute, and the kilograms are the kilograms of the solvent. So when the freezing or boiling point of a solution is known, we can then, just like what we've done right now, is we have found the concentration, the molality of the solution. And so the first thing that we have to do to get to the molar mass is number one, we have to use the freezing or boiling point and that constant, Kb or Kf, to determine the molality. Now, this step right here, that's exactly what we just did. We took the constant, or we took the the change in the freezing point, we took our Kf value, and we found the molality of the solution. So number one, we've already done. Number two, we're going to convert the molality to moles using the given kilograms of solvent in the problem. So just like on this last problem that we just did, our answer was 0.672. So if our answer is 0.672, that's 0.672 moles of solute over kilograms of solvent. So the second step right here is saying, okay, if we have our molality and in the problem they give us, it's given the kilograms of the solvent, let's look at our problem here. If we take our molality and we multiply by however many kilograms of solvent are in the problem, what's going to happen here is if we multiply by kilograms of solvent, the kilograms of solvent over the kilograms of solvent are going to cancel, and we're going to be left with moles of solute. So on step number two, we're going to multiply by the kilograms of the solvent to get the just the moles of the solute left. Because remember, what is molar mass? How do we measure molar mass? We measure in grams per mole. So really, that's what we're trying to find. We're trying to find the grams of the solute and the moles of the solute. Well, here are the moles of our solute. Because now our last step, step number three, is we're going to divide, again, the given, that means they're going to be given to us in the problem, the grams of the solute by, right here, the moles of our solute. So let's see this happen. Let's actually do a problem. It says 4.63 grams of an unknown substance. So that's our unknown. It's dissolved in 425 grams of benzene. And the freezing point is 0.924 degrees below the freezing point of pure benzene. So that right there is telling us how much the freezing point went down by. And so then they want to know what is the molecular mass. And again, when they say molecular mass, that's the same thing as saying the molar mass. What is the molecular, atomic, molar mass? It all means the same thing. What is the molar mass of the solute? So step number one, let's go back. Step number one, use the change in the freezing or boiling point to determine the molality. So in this case, we're dealing with freezing points. So we know that our equation is delta TF equals KF times M. And in this case, we're looking for the molality. So the change in the freezing point is 0.924. So 0.924 degrees Celsius is going to equal the freezing point constant, 5.12 degrees Celsius, times our unknown, our little m. So to get little m by itself, we're going to take 0.924, we're going to divide by 5.12, and I'm going to get a molality equal to 0.180, and again, that's moles over kilograms. Okay, that's just like the first example that we already did. Okay, so that's what we did here. Step number one is we use the change in the freezing or boiling point to determine the molality. The molality of our solution is 0.180. Okay, step number two, convert the molality, so 0.180 moles over kilograms. And again, this is the moles of the solute. This is the kilograms of the solvent. So the solute, remember, is the stuff that gets dissolved. The solvent a lot of times is water, but it can be anything that dissolves the solute. So let's go back here because our next step is telling us we have to basically get rid of these kilograms of solvent on the bottom. So let's come back to the original problem. It tells us that 4.63 grams of an unknown substance is dissolved in 425 grams of benzene. So that's telling you right there that benzene is the solvent. So we can use that mass of benzene, the 425 grams of benzene to get rid of our kilograms on the bottom. So we're going to multiply by the kilograms of benzene. So I'm going to move my decimal point 3 spaces over. 0.425 kilograms. Kilograms cancel. And so now I'm just going to multiply 0.180 times 0.425 equals moles is all that's left, 0.0765 moles. And again, that's of my unknown solute. So step number 1 was to get the molality. Step number 2 was to multiply by the kilograms of the solvent to get the moles. Step number 3, our last step, is to divide the given, again, that means it's in the problem, grams of the solute by the moles of the solute. So let's come back here. First of all, here's our moles of solute, 0.0765. So we have 0.0765 moles, just to get it over here so it's all on the same page. And then back to here, we have 4.63 grams of that unknown substance. So we have 4.63 grams of it. So again, molar mass is grams per mole. It's grams on top, moles on the bottom. So it's 4.63 grams divided by 0.0765 moles. And then it's just to our calculator. 4.63 divided by 0.0765 equals a molar mass of 60.5 grams per mole. And that is the answer to our question. We have found the molar mass based on the information given in the problem using freezing points and boiling points. All right, here's another example. So again, this is a good time for you to stop the video, pause it please, and try to do this problem by yourself, and then come back and I will go through the problem for you. All right, so here we can see we've got 0.250 grams of some substance. It's dissolved in 40 grams of CCl4, carbon tetrachloride. The boiling point, it looks like, is going up by 0.357, and they want us to calculate the molar mass. So I'm going to do as much as I can on this screen just so I don't have to flip over to the other screen. So step number 1, remember, is to get the molality. So the molality is going to be delta TB equals KB times M. So the change in the boiling point is 0.357. The boiling point constant for carbon tetrachloride is 5.02. And we're looking for the molality. So to get molality by itself, I'm going to take 0.357 divided by 5.02, and I get 0.0711 is my molality, and that is step number 1. Step number 2 then tells me I need to multiply my molality, 0.0711. I'm going to multiply that by the kilograms of the solvent. So we're dissolving 0.250 grams of the substance in 40 grams of carbon tetrachloride. So the carbon tetrachloride is my solvent. So I'm going to multiply that by 0.040 kilograms. Remember that I have to move this decimal point 3 spaces to the left, and that puts a 0 out here. So I'm going to take my answer from my calculator. I'm going to multiply it by 0.040, and I get 0.00284 moles of the solute left. That says 0.00284. Okay, and now my last step, step number 3, is to take the grams of my solute, 0.250 grams, 0.250 divided by 0.00284 equals 88 grams per mole. And that, again, is our molar mass. Now, some things that I might do to try to trick you is I might say, which gas is it? And I might give you some choices, but basically what you're looking for is you're looking for the solution that or the solute that has a molar mass around 88 grams per mole. So I might say something like, is it is it C3OH? Is it C2H5OH? Is it C4H10O3? And basically whichever one adds up to 88 grams per mole using the periodic table, that's what's going to be your answer. So you can identify different substances based on how much the freezing point goes up or how much the boiling point goes down.